Good morning, students. Welcome to the online physics class. I am Amos Michael, teaching physics in Mount Zion Matriculation Higher Secondary School. So, in this class, we are going to discuss about the different types of levers. There are three types of levers are there. First one is class 1 levers, second one is class 2 levers, and finally class 3 levers. So there are three types of levers, and depending upon the position of the fulcrum, that is pivot, effort and the load, we are classified into types. So before going to that, what do you mean by a lever? A lever consists of a rod that is free to move about a fixed point. Here, a man, look at this picture, a man is trying to move the boulder from the way. So boulder is nothing but a huge rock, and this is called a fulcrum. That is a small stone. It is fixed. So with respect to this point, this rod can move freely. So this rod is the lever, and this is called fulcrum, and this is the load, and the applied force by the man is known as effort. So the small stone supports the rod. The point at which the rod touches the stone is fixed and it does not move, and this is called fulcrum. And the force that is applied by the man to move the boulder is called effort. So that's all about the small introduction about a lever. So as I already mentioned, depending upon the position of the fulcrum, effort and the load, the levers are classified into three types. So first type is, here look at this picture. This is a seesaw. This is a example of seesaw. It is a bar which can move up and down freely along its fixed center. Okay, this is a fixed center. So with respect to this fixed center, this bar can move up and down. Okay, that's it. Then if you apply a force on one end, and it will raise the object on the other end. So you might all have very familiar with this seesaw. So this seesaw is the best example for class 1 levers. Here the fulcrum, that is the fixed point, or otherwise you can also call it as a pivot, and it lies between the effort and the load. So seesaw is a bar which can move up and down freely along its fixed center. So here this is the fulcrum, and this is the effort, and the load is placed on one end and the effort is placed on the other end. So here the distance between the fulcrum and the load is called a load arm, and this distance between the fulcrum and the effort is called effort arm. So later this concept will be very useful in the topic of principle of levers. So on that time you must know that what do you mean by load arm and effort arm. Simply load arm means the distance between the load and fulcrum, and the effort arm is the distance between the fulcrum and the effort. So what are the examples of a class 1 levers? So the oars of a boat. Here this is the oars of a boat. So man is sitting on a boat. So this is the oar of a boat, and this is the waves, the tides of the sea is the resistance, or otherwise you can call it as a load, and the fulcrum is the fixed point, and it is this lever, that is this rod is fixed at this point of the boat. So this is considered as a fulcrum or pivot, and this one is the effort, that is the man applying force on the lever, and this is called effort. So the oars of a boat is a good example for the class 1 type levers. And second one is a pair of pliers. This is a plier, otherwise simply you will call it as a cutting plier. Okay, so here this is the arms of the plier, and in these arms we are going to apply the force. So the place at which we are going to apply the force is the arm of the plier. So this is called the effort. Here the two pair of pliers is fixed about the fixed point center and is called as a fulcrum or pivot, and the load will be placed in between the two arms of the pliers. And so here the load, that's the resistance, the oppositions will be placed in the center place between the two arms of the pliers. So similarly, a pair of scissors, you can consider as a pair of scissors. Scissors, everyone you know scissors are used to cut the clothes, isn't it? So scissors, a pair of scissors is fixed at the center, and this point is known as pivot or fulcrum. So the paper, which is here, the paper is acts as a load, and it is placed in between the two pairs of scissors, and the effort is applied. That is, the external force is applied on the handles. Okay, and kata bolt is another example of class 1 type levers. So that's all about the class 1 levers, and now we will pass on to class 2 levers. So if the load is placed between the fulcrum and the effort, it forms the class 2 lever. You look at this diagram. Here, this is the fulcrum, that is the pivot. Fulcrum, another name for pivot is fulcrum. So the fulcrum is at one end, and the load is placed in between the effort and the fulcrum. Okay, so the load is placed at the center, and this is nothing but the lever. The green bar is nothing but the lever. So load is placed on the lever at the center, and the effort is applied at the other end. So here the load is placed in between the fulcrum and the effort. As I said, it forms the class 2 type lever. So look at this diagram. The case of wheelbarrow, the wheel is placed at the front and act as a fulcrum. So here the wheel acts as a fulcrum, and it is fixed and it is placed at the front. Okay, so the load or object to be lifted is placed at the center. Here usually the object or the load will be placed in the basket. So here the load is placed at the center, and the force that is opposite to the direction of the load, the effort will be always in the opposite direction in the case of class 2 levers. So in order to lift this load, the effort is, that is the external force, is applied in the upward direction. So this external force applied in the upward direction is called effort. Okay, now we must understand thoroughly what do you mean by class 2 levers. Class 2, whereas in the case of class 1 levers, what do you know? The fulcrum lies between the effort and the load. Here the load, that is the load, it lies between the effort and the fulcrum. Now we'll move on to the next slide. So what are the examples of class 2 levers? So here the nut cracker is a very good example for class 2 levers. So this is nothing but, this is the fulcrum, that is the fixed point. So both the arms of the nutcracker is attached in this point. So this point is fixed, and this is called a fulcrum. And the nut, the walnut, for example, if we take a walnut and it is placed at the center, so it is considered, the walnut is considered as a load, and the force that is applied on the handles is the effort. So look at this, a man is applying a force, huge force at the handles, and thereby the nut is cracked into pieces. Okay, so another example of class 2 levers is bottle opener. So look at this here. So wheelbarrow, nutcracker, another one is bottle opener. Here the fulcrum is at the one end, the effort, that is the external force applied on the handles, is at the other end, which is opposite to the direction of the load. Okay, So in a bottle opener, fulcrum is located at one end and the load is the cap of the bottle which lies in the middle of the opener. Here the load is nothing but the cap of the bottle and it lies in the middle of opener. So the next one, the effort is applied at the handle which is applied opposite to the direction of the load. So that's all about the class 2 levers. Now we will pass on to class 3 levers. So here you look at this. Here the effort is applied between the fulcrum and the load. Already I told you effort is nothing but the external applied force, the applied force on the machine, that is the lever, simple machine, that is the lever. The fulcrum is the fixed point and the load will be an object. Okay, so you look at this in this picture. This is a very good fishing rod. What is this? This is nothing but the fishing rod. Okay, here the fish is the object, so it is the act as a load. So here the man applying a force in this center, at the center of the lever. So this is nothing but the external force applied at this point is called effort. And another point, another end is fixed. It is kept in hand by the fisherman. So if you look at carefully in this picture, he tried to hold a fishing rod on his legs. Exactly, if you want to say exact position, he trying to hold this fishing rod at the hip. So this point is fixed and the effort is applied at the center and the load is nothing but the fish. Okay, so in the middle of the rod where the force is applied to catch the fish is the effort. The fish hangs on the other end. You look at here, the fish hangs in this other end of the fishing rod is the load. So what are the examples of class 3 levers? So tweezers, you look at this, what is this? Tweezers are very much useful in the case of surgery. So surgeon they will very often use this instrument is called tweezers. It is used to remove some external particles present in our body. Look at this. So here what is the best noticeable thing is this tweezers, it decreases the external force. It decreases the force. That means it decreases the external force. So this man is applying huge force. As a result, a small external particle is removed from this point. So this tweezers reduces the special case of class 3 lever is lever. Particularly this tweezer, it reduces the external force. What is this? This is nothing but a sugar tongue. So this picture is shown here. So this is the nothing but sugar block of sugar is here. So in foreign countries they used to add sugars as the solid particle, a solid rigid one. Or you can call it as a sugar block. Okay, so this is nothing but the sugar tongs. So what do you mean by sugar tongue? A device consisting of two connected arms that you push together and use for picking up lump of sugars. So as a lump of sugar, they will add into the tea. So in order to pick up a lump of sugar tongues are used. Here you look at this. Here is this the fixed point, this fulcrum, and the load is nothing but the lump of sugar, and the effort in order to hold this lump of sugar, the effort, that is the external force, should be applied at the center. Okay, So therefore these sugar tongs can be considered as a class 3 levers. Why? Because so effort is applied between the fulcrum and the load. Okay. So another one is fishing rod. This is already we have discussed. You look at this here. The fishing rod is usually it will be mounted or fixed at some point on a boat. Okay. So here the fulcrum is at the center. Fulcrum is at one point, and here they will apply a force in order to what do you call it? In order to catch the fish, and the fish will be at the other end, that is the load will be at the other end. So next one we are going to see what do you mean by a principle of a lever. So this diagram we have already seen in the first slide. So this is nothing but a class 1 type of levers where the fulcrum is between the load and the effort. So here the load, the opposition force resistance is placed at the one end and the effort is placed at the other end. The distance between the load and the fulcrum is called as load arm, and the distance between the effort and the fulcrum is known as effort arm. So the principle of levers is the product of load and load arm equals the product of effort in and effort arm. So if you multiply this load by its distance, and that will be exactly equal to this the distance product of this distance and this effort. So load times the load arms equals the effort times the effort arm. Okay. So in other words, you can also say the product of load and load arm equals the product of effort and effort arm. Okay. So this equation can be rearranged. How it is rearranged? You look at carefully. Here the load is on the left hand side. This is the center part, that is equal symbol. So this is your left hand side, this is your right hand side. So this load is on the left hand side and effort on the right hand side. So this when effort comes to this side, this left hand side, it comes to the denominator. So this one is a numerator and this one is a denominator. So load by effort equals to effort arm by load arm. When this load arm on the left hand side, when it comes to the right hand side, it comes as a denominator. So this equation can be modified as load by effort is equals effort arm by load arm. But we know that mechanical advantage. What do you mean by MEA? Simply mechanical advantage is a short form of mechanical advantage. The previous class we saw the definition for mechanical advantage. What is the definition? It is defined as the ratio of load to effort. So once again you look at the left hand side. Left hand side what you are having? Load to effort. So this can be rewritten as a mechanical advantage. So mechanical advantage, that is load to effort, is equal to the effort arm by load arm. So this is the another way of defining mechanical advantage. So in the previous class we have seen that mechanical advantage could be defined as the ratio, that is the ratio of load to effort. So another way of defining mechanical advantage is effort arm by load arm. And hereafter we are going to see some simple problems. What are they? So example 1. So a wheelbarrow has an effort arm 120 centimeter long and a load arm 40 centimeter long. What is its mechanical advantage? Just now you have seen there are two formulas for mechanical advantage. One is load by effort, another one is effort arm by load arm. So inverse over. Okay. So here the given data are 120 centimeter and 40 centimeter. Effort arm is 120 centimeter and load arm is 40 centimeter. So the mechanical advantage, formula for mechanical advantage MEA is equal to effort arm by load arm. So effort arm 120 centimeter, load arm 40 centimeter. So 0 0 will get cancelled. So 1 4s are 4, 3 4s are 12. So 12 by 4 equals 3. So mechanical advantage is equal to 3. So from that we conclude that the the wheelbarrow has a mechanical advantage of 3. Or in other words, the mechanical advantage of a wheelbarrow is 3 in this case. So what is the question? What is the mechanical advantage in this case? So the wheelbarrow has a mechanical advantage of 3. So there are no units you have to keep in your mind. Since it is the ratio, there will be no units at all. Next we are going to see the second example. What is the second example? The effort arm of a lever is 120 centimeter long and the load arm is 80 centimeter long. What is the effort needed to raise a load of 60 Newton weight? What is the mechanical advantage of this lever? First thing is we have to find the effort. Then we will be applying this value of effort to the mechanical advantage formula. Okay, so what is the formula needed to find the effort? Look here, the given data are effort arm length is 120 centimeter, load arm equals 80 centimeter, and the load is 60 newtons. So load is nothing but a force. So unit of force is Newton. So simply from the symbol of the unit we can identify which one is a effort or which one is a effort arm. Okay, so the mechanical advantage formula for mechanical advantage is load by effort or effort arm by load arm. So we are taking this formula. So effort arm 120, I am replacing this value from here. 120 is the effort arm length, so 120 in the place of effort arm. Load arm value, the given load arm value is 80 centimeter, so I am writing here the place of load arm. So load 60 is also given in the problem, so you have to find the value of effort. Okay, so very first and foremost thing is you have to derive the given data from the example. That's very important. Okay, so this from this in this formula we have substituted the given data in the problem. Now we are supposed to calculate the effort. So effort should be at the one side of the equation. So what you should do is effort, it can be taken to the left hand side. So here the effort is taken to left hand side, and right hand side we have 60. When this 120 by 80, when it goes to the right hand side, what happens? It will just turn its ratio upside down. That means the denominator 80 becomes a numerator, and the numerator becomes a denominator. Okay, so when this 120 by 80 on the left hand side, when it goes to the right hand side, it just become 80 by 180. So 80 goes cross multiplications, nothing but simple mathematics, a cross multiplication. Effort is taken inside, 80 is taken as a cross multiplication, 80 is taken to the numerator on the right hand side, and 120 goes to the denominator, the left hand side. So 160 straight away you can cancel here. So 0 will get cancelled. So 1 6 are 6, 2 6 are 12. So here we will be left with 2 when 80 by 2 is equal to 40. I hope you understand. Or 160, 260s are 120. 60, if you multiply 60 by 2, you will get 120. So if you cancel 60 by 180, you will get 2 here, that is the denominator. So 80 divided by 2 is equal to 40 newtons. But what is now we have calculated only the effort. What is the effort needed to raise the load of 60 newton? And final thing is we are supposed to calculate the mechanical advantages. So what is the formula for mechanical advantage? There are two formulas. As I told earlier, there are two formulas. One formula is effort by arm, effort arm by load arm. Another one is load by effort. Now we know the value of load that is given in the problem 60, and we have calculated the effort as 40. So mechanical advantage is load by effort. So 60 by 40 will get, if we cancel, you get 1.5. So finally the lever has a mechanical advantage of 1.5. So 0 0 will gets cancelled. 4 you have to divide 6 by 4 means 1 4s are 4. So 2 will be left with 2. So you place a point and add 0. If you add 0 near 2, it will become a 20. So 5 4s are 20. Okay, so that's how you have obtained this value of 1.5. Now we will move on to the next problem. So a rod of length 1.2 meter has its fulcrum situated at a distance of 0.2 meter from the load. Calculate the mechanical advantage of the rod. So this is the problem. You have to derive the given data from the problem. So length of the load arm given in here, this problem is 0.2. Okay, and the length of the effort arm is 1.2 minus 0.2 is equal to 1. Why? So a rod of length, the total length of the lever is 1.2, has its fulcrum situated at the distance of 0.2 from the load, that is the load arm is 0.2. So if you want to calculate the length of the effort arm, then you have to straight away subtract the value of this load arm value from the length of the rod. So if you see in the previous case, this one is the total length of the rod. If you subtract this total length of the rod if you subtract the what do you mean, the load arm length from the total length, you will get the effort arm length. Okay, so this is very simple strategy you have to keep in. If you look at the previous if you have any doubt, you pause the video and you go to the previous slides, that is 3-4 slides before, and once again you see the type 1 lever examples, and then you come to, if you come here, you will probably understand very good. So here once again, as we know, the very known formula, mechanical advantage is equal to length of the effort arm by load arm. So effort arm length is 1 meter and load arm length is 0.2. So 1 by 0.2 is nothing but 5. It is not 1 by 2. 1 by 2 means 0.5. It is not 0.5. 1 by 0.2. So in order to make it this number as a whole, fraction as a whole, what you will do? You multiply and divide by 10. If you multiply the numerator by 10, it will become 10. 1 into 10s are 1 10s are 10s, and if you multiply the denominator 0.2 into 10, you will get 5. 2, you will get 2. 0.2 into 10. 0 multiply and divide by 10, isn't it? So if you multiply the numerator by 10, you will get 10. If you multiply the denominator by 0.2, and you will get 2. So 10 by 2 is equal to 5. So the rod has a mechanical advantage of 5. Okay students, what is the assignment in this class? So you have to read it loud from page numbers 71 to 73, and what you have to do is you have to mark all the keywords present in the corresponding pages. Then you have to draw the diagram in your classwork note, and the reference figure is given in page number 71, figure 4.5. Okay, so this is the example of class 1 levers. So in order to understand the whole concept, or in order to perform the calculations, you must be very familiar in this picture that is given in page number 71, 4.5. So that's why I'm asking, that's why I have given this as a homework. All of you must draw the diagram in your class note, the figure 4.5, page number 71. And then you have to study the OTQ. What do you mean by OTQ? Objective type questions. A3, A5, P3, P4, C6 and C7. And you have to study the question and answers H1, H2 and H3. So these are the assignments. You have to do your assignments then and there. Don't accumulate your assignments. So that's all about my dear students. I hope you will be very familiar. You would have understand the concepts. That means the different types of lever. What do you mean by lever and its different types very well. Thank you for your cooperation. Thank you. Have a good day.